What we're going to start with today is looking at something that's a reminiscence of stuff we've done in the past. So it shouldn't be too out of the ordinary. But what we've got are, if we look at problem number 1, right here, and it's on the top left of the very first page of this handout. So make sure you're looking at that particular page. If you look at problem number 1, there are 2 similar triangles. And we know they're similar. It actually tells us that. If you look up at the top, it says the triangles in each pair are similar. Right there. So we know we have similar triangles. All right, guys? And what we're going to do is we need to solve for a missing side length. So before we do this, it's a good idea to kind of match up your shortest side to your shortest side, your medium to your medium, and your long to your long. So the shortest side in our top one is what? Okay, PQ will correspond to what? ED. And I'm drawing the squiggles here to show that they're not congruent, but they are similar and they're proportional to each other. All right, the mediums will be what? What are the kind of medium length sides? So on the top one, which side is the middle length?
30.
Okay, 30. And what do we name that side? RQ. And that means for the bottom one, it's going to be what? CD. And therefore, the longest are going to be, we don't really care as much about these because there's no information, but RP and CE are going to be the longest. So it's kind of important to identify which one's your shortest, your medium length, and your longest length. Okay, so now, if we're going to solve for this missing value, what are we using? A proportion. Now fill in that proportion. What do we have? Okay, we can do 25 over 30 equals what? 65 over x. So that does work. All right. So we've got 25. If we do the cross products here, I'm not going to do the cross products for the next one. We'll just set up our proportion. But cross products here, we have 25x. I can tell you that. But you guys have to tell me, what is 65 times 30? $1,950. All right. Let's get x. And what is that going to be? All right. So we can come up with our final value for our missing value. What is it? 78. All right. You guys should have calculators. You should be able to do this. It's a basic equation to solve. So that's why I'm zooming through that. So our missing side length is 78. And that's all well and good. Our main purpose for today, we're not super interested in that. And you'll see what we get around to and how we use this today. But it's good to compare. It's good to do these types of problems to get ourselves prepared. Okay, so let's look at the next one, problem number 2. And let's find the corresponding side lengths. So what's the shortest side length in the top triangle? Okay, it's going to be DE right here. And what's the shortest side length in the bottom one? All right, KL, LK, whatever you want to call that. So this is one where it's easy to make a mistake because a lot of people will just naturally do the DE and the KJ and say that, anyways, they'll pick the wrong sides. So our question mark corresponds to what? To the 65. And then I know that this one's like probably the medium length side right here. But let's just set up our proportion. But let's set it up where we compare the opposite sides. So the corresponding sides. X over what corresponds to it? What value corresponds to x?
65.
65 equals what?
CD over...
We're setting up actual numbers here. So x over 65 equals 63 over 45. All right, you can see the pattern of correspondence as you set up your proportion. So x over 65 equals 63 over 45. And I know it looks like we kind of flipped it around, but that's because these two triangles have been rotated. One of them has been rotated. So that kind of flips around our perspective a little bit. Okay, I'm not actually going to solve that proportion. I don't care a whole lot about x. But I just wanted to cover that idea. And the next thing you'll need to do is actually in the Google Classroom, I uploaded a new, 4 worksheets last night. If you go there in the main thread, it should say similarity criteria. Maybe it also says a similarity criteria. And then the very first thing, it says similarity criteria handout. So I'll give you guys a minute to get to that. All right, I'm going to try and be very clear as I go through this about what our goal is. And we can start off clear enough. Let's identify what it means to have similar figures, similar triangles specifically. All right, so you can see these questions at the top. So if you have similar triangles, what's going to be the same about them? The shape. And so I'll write shape, but we can be a little bit more specific when we say the shape. So what measurable thing is the same about them? The angles. There it is. The angles. You can measure angles, and the angles will all be the same. So I'm going to put angle measures, or angles are congruent. I'll just make sure it's very clear. Okay, so you've got two similar triangles. All the angles are congruent, but what's different? The size. And we say the size is different. What are we really saying? Say that louder. The side lengths are not the same. All right, now the side lengths are not congruent, but what are they? They correspond, and they are, there's a word I throw out a lot. Not congruent. What's that? Well, they could be in dilations, so you're kind of right about that. You got the right first letter. You can say proportional. There it is. Side lengths are proportional. And we'll make sure that we're going to get some examples of doing this today. I mean, you've used proportions a lot. So we can combine these and come up with our formal definition. And it's not overly technical. We've already written the most technical part of it. We'll just combine this together. We'll just say in similar triangles, angle measures are congruent. And side lengths are proportional. highlight that. All right, so there's our formal definition. It's pretty straightforward. I think we can all agree with this. So the main idea for today is we're talking about similarity criteria. And you can see that the next little section right there. So we talk about similarity criteria. This goes back to something we did last semester. We want to guarantee that two triangles are similar. Not congruent, but guarantee that two triangles are similar. And we have a certain set of similarity criteria that we're going to come up with today. If you think back to last semester, we were trying to prove that two triangles were congruent. And congruency had their own set of rules. They had congruence criteria. Now, if you read this astutely, you can find them again, but can anyone name one of the congruence criteria? Side, side, side. There we are. So, if I'm just going to draw a couple triangles up here that are congruent. So, if I've got two congruent triangles, that means all the sides are congruent. If it meets side, side, side criteria. Okay, so there's one of them. What was another?
Angle, side.
Angle, side, angle. So let me... All right, if I've got an angle and then another angle and a side in between, there it is. In that kind of situation, you can see that's angle, side, angle being met. All right, you guys remember that? Do we need to see the other two? You got it. Okay. So those are congruence criteria. Similarity, we can approach that a little differently because we don't care as much about the way that we prove it can work a little differently. Thank you so much. All right. It's going to be a good day. All right, so similarity has 3 criteria. Congruence has 4, similarity has 3. All right, so if any of the criteria are met, and no triangle as given is going to meet all 3 of the criteria, unless they give you all the information, in which case we don't need a criteria, we can see it. But anyways, if any triangle meets one of the 3 criteria, then we can say that those 2 triangles are similar. So it's an important thing to remember. We're only trying to prove that 2 triangles are similar, not congruent. And we just wrote down what similar means. So we've got 6 ways of combining information here. The possibilities are angle, 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 side, angle, 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 side, side, angle, side, 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 angle, side, side, side. And you'd have to think back a while ago. But we looked at all 6 of these possibilities, and we determined there were only 4 that worked for congruence. Let's see how it works. No. All right. So we're going to start with angle, angle, angle. So I'm just going to, in these triangles right here, you guys have this on your worksheet. You can fill this in too. If these 3 angles are congruent, what do you think? Are these 2 triangles similar? Okay, I'm getting yeses. Anyone disagree? Okay, now we're not going to go through and formally prove this in any way. We have some mathematical ways of proving it. But let's just say that, well, yeah, if your sides are all congruent, if your angles are all congruent, then necessarily the side lengths have to be proportional. And you can just take my word on that. So bottom line, if we have the angle, angle, angle criteria met, we're good to go. But let's go one step further than this. Could we get away with fewer than 3 angles? Let's say I don't tell you that all 3 angles are congruent. What's the fewest you need to know? 2. So why can you get away with only knowing 2 angles? Say that again. A triangle adds up to 180, triangle sum theorem. So if if these two angles are the same, we can even plug in numbers, and we don't have to do all the math, but let's say this is 40, let's keep it nice round numbers to make our math easier. So if that's 50 degrees and this is 60 degrees, and we know these are congruent, what's our third angle going to be? It's going to be 70, and some of you aren't necessarily doing that math in your head, but that's okay. We know they all add up to 180, so that 50 plus 60 plus our third angle would have to add up to 180, and you would get 70. So I guess we are doing the math here. So this has to be 70 degrees. So here's the bottom line. If I only gave you two angles and they were both congruent, then that would mean that all three angles are going to be congruent. So we have kind of this chain of logic that follows. And so I'm going to go ahead and erase that 70 out of there. And let's follow the logic. If two angles are congruent, then that means all three angles are congruent. If all three angles are congruent, then the triangles are similar. So we can kind of jump. We call this sometimes the transitive property. So it says, if two angles are congruent, then that means the two triangles are similar. All right. So are these two triangles necessarily similar? To answer that question, we say yes, and we can add a little extra to this. We can say, and only two angles are needed. Only two congruent angles are needed. So this is what we call the angle-angle similarity criterion. So if it's multiple, it's criteria. If it's singular, it's criterion. But it doesn't matter to me if you call it criteria all the time. So that's angle-angles. And the name makes sense. It's basically saying, if two angles are congruent, we're good to go. And that's, now this can take care of a few things. Let's go back to the 6 possibilities. We started with, up here at the very top, angle, angle, angle. What about angle, side angle? Are those going to be congruent? Or sorry, are those going to be similar? How do we know? There's 2 angles in it already. So, and then angle, angle, side. Those 2 angles. So here's what I'm going to do. I'm going to cross these out. And I'm just going to replace all of this with angle, angle, similarity. So of the remaining 3 that we haven't checked yet, which criteria did we not use before? Which one did we decide cannot be used? For congruence. Side angle. Side angle side was fine. Side was fine. But side angle does not work. All right, so we're going to, and we're not going to go through a complicated proving process here. I'll go ahead and tell you, these still work. So I'm going to go ahead and say side angle side and side are also going to work to prove similarity. But there's a key difference. When we're trying to prove 2 triangles are congruent, we're saying that the sides are congruent and the angles are congruent as well. When we're trying to prove similarity, what are we trying to prove about the sides? That they're proportional. So that's the very last thing right here. The same ones, side angle side and side, also prove similarity, but the major change here is that the sides are proportional. Not congruent. And so our three similarity criteria, we have different ways of writing these. And we already know angle, similarity. I already told you that one. So when you're talking about side, angle, side, we don't want to confuse it with congruence. So we always add this similarity tilde there at the end. So side, angle, side, similarity. And side, 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 similarity. Sometimes people write out the word similarity next to it, but this serves the same purpose. Saves time. So this is it. I mean, it looks familiar. It's going to work a little differently. I'm going to go through a few examples of what is left in class. And then tomorrow, because you won't be here, just take some time, look at this a little bit. Thursday, you'll have your wrap-up activity. It's not a quiz, but you'll have some kind of a wrap-up activity with this, and we'll call it good. So you're done with this handout. In this, go back to the Google Classroom. You can download the worksheet. The very next is part of the same thing, so you already saw it. But download the worksheet, and when you have it, it will look like this. All right, let's start with the very first one. I can't, I'm using a different app, so I can't quite zoom in, but you guys can zoom in on number 1 in the top left. And if you zoom in on that, the basic question is, are these similar triangles? Okay, yes, they are. And so this is what you're going to say. Yes, these are similar triangles. For what reason? Angle, angle, similarity. So angle, angle, a lot of times is really easy. Not always. I mean, it can be set up to be more difficult. But if it's something like this, it's just a quick glance. Okay, those two angles are congruent. Those two angles are congruent. Therefore, yeah, angle, angle has been met. And you can see these are the congruent angles here. All right, pretty straightforward. We don't need to spend time on that one. The next one. This is where the proportionality of the sides comes into play. So the only way to check if these two are proportional, or if these two are similar, is to make sure all the sides have the same proportion. And this is where the first thing you want to do, because it's easy to make a mistake with this, the first thing you want to do is match up your shortest side to your shortest side, your medium length side to the medium length side, and the longest to the longest. So what are my two shortest sides in these two triangles?
2.8 and 5.6.
There you go. So I'll just kind of mark those with the same symbol. What's our two medium length sides?
Actually, it would be 3.5 and 6.
There you go. And the important thing is just that you match up the corresponding sides, and you don't have to go in order, short, medium, long. And that means, of course, 4 and 8 are the two longest sides. So I'll just mark that real quick. If you want to mark the actual sides, I think it's a helpful thing. Otherwise, just mentally think those are the two shortest sides. So now let's create, this is going to be a weird looking proportion, but there's no missing side length. We're not solving for anything with this. We're just checking the proportionality that's there. All right, so I want to set up 3 different ratios. I want to set up the ratio of my short sides. So what could that look like?
2.5.6.
So 2.8. And then where am I going to put the 5.6? Okay. We're creating a ratio, so yeah, it's going to be our denominator here. Now you could flip it around as long as you keep it consistent. But I'm going to go from the shorter triangle, or from the smaller triangle to the bigger one. So 2.8 over 5.6. What about my medium length sides? What's my ratio going to be?
3.5 over 7.
There it is. 3.7. 3.5 over 7. And then the longest ones are going to be 4 over 8. The way you check proportionality, use your calculator. Divide all these, turn them into decimals, and see what decimal you get. So what's 2.8 divided by 5.6? 0.5.
The other one's 0.5.
Yeah, so 3.5 over 7 is
0.5.
0.5. And 4 divided by 8 is
0.5.
0.5.
So yes, it is.
All right, and this is what we're looking for. We're looking for the exact same proportion for all three of our ratios. The exact same ratio for all three, I should say. And 0.5, 0.5, 0.5, exactly 0.5 each time means, yes, these are proportional. So, are these triangles similar? And what criteria did they meet? Side, 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 similarity. All right, so that's about as complicated as it gets. I'll do a couple more in the time that we have. And you'll notice this worksheet has, I think, a front and a back to it that has a lot of practice. So if you can run through this and really feel like you've wrapped your head around it and you understand the concept, that's all we're really dealing with, the similarity criteria to this extent. Okay? I'm not going to make you guys write proofs with it, which would make it another level of complication. Okay, so the next one, let's look at C, just because this one's a little bit weird. If these are similar, what criteria are they going to have to meet? Yeah, the only one that could possibly work here is angle. And initially, I mean, we're off to, I don't know, a decent start. Two angles, so one angle in each triangle is congruent. But obviously, 60 and 53 are not. What can we do? Well, we can still check this further. What? There you go. Use your triangle sum theorem. Come up with your missing angle. So I don't know which one you want to do. Doesn't really matter. So let's find a... here, I'll go ahead and tell you. We're going to solve for this x right here in the bigger triangle. We're going to solve for that missing angle. Use your triangle sum theorem. We know these three have to add up to 180. So tell me what x is going to equal. What was it? Okay, I know we had some fast answers, but I'll just set up the equation real quick so everyone at least can see that. We'll have 60 plus 57 plus x will add up to 180. And you said the answer was 63? So x equals 63 when you go through and do that. All right, so now we can do a real apples-to-apples comparison. And are these two triangles going to be similar?
Apparently,
no. No. So, yeah, there's only one angle that matches up. All right, I'm going to skip down to the bottom part. And if you'd like to, we can go through another one of these with setting up proportions. Or unless you feel like you got the hang of it, and then you guys can just practice with the remaining time. You want to do, let me show on the screen right here real quick. Do you want to go through problem D, or do you feel like you understand what to do?
let's go with D.
Okay. I think I was hearing people say, let's go through it. I mean, if you don't need to go through it, I don't mind if you take this time, just get started and practice with the problems on the page. All right, so we just want to match up short, short, medium, medium, long, long. I'm going to just do that up on the screen. You do this on your own, and you can just check up here when you're done. Make sure that you agree. All right, what do you think? Is that what everyone marked their triangle with? Something to that? Something like that? All right, so let's set up our proportions, our ratios. What's the first ratio going to be? Okay, we got 4 over 4.8. We've got, what next? 5.5 over 6.6. And the last one is 8.25 over 9.9. All right, you can just do the division for all three of those. I won't actually finish it from here. We set up our equivalent ratios, and we're checking to make sure they really are equivalent. So do the division. If you get the exact same decimal for all three, then yes, they are similar. If anything is even slightly different, then just say no, they are not similar. And I'll just leave it there. You guys can practice. If you have questions, let me know.